Hey, this is Mr. Ward, and welcome to our first episode of I Am Stuck. So I am responding to a few folks who said they were stuck on particular topics, and this one will focus on slope. Now, the first place you want to go when you're trying to get information on how to do something, if you haven't already done so, you want to go to this main document, Algebra Linear Tasks and Choices, and you want to find the topic. We're going to start with slope here, which you just click on this and it'll bring you down to where you need to be. And there's a whole lot of information and examples on slope. So first of all, slope is one of the most important concepts we'll be learning this year. We'll be using the concept of slope in all of your math classes going forward through calculus and beyond, and also in physics and chemistry and all sorts of business applications and so forth, any kind of understanding of economics, you'll be using slope, and you'll be using it in your everyday life as well, even when you don't realize it. Slope is a measure of linear change. It is a rate. It is a ratio of the change of the output, which we usually call y, over the change of the input. Okay, and we usually call input x. So we often talk about it as change of y over change of x. Now I'm going to go back. So I'll actually go through here. You can give you a quick tour. We use the letter M to represent slope. And I've given some examples that if you haven't taken a look at, you should take a look at. And here we have on the next page the slope formula for calculating slope. So it's often called rise over run. And the reason we use the word rise over run is we're talking about the output change, the change of the output versus the change in the input. And the rise is a vertical word and run is a horizontal word. And vertical relates to the y variables and horizontal relates to the x variables. So when you hear miles per hour, for example, that is a slope. That is a rise over a run. If I were at one distance and then I would add a new distance after a certain amount of time, I find out the change in my distance and divide by the amount of time that has passed, and I'll have an average rate of how fast I went, called speed, miles per hour, meters per second. So this is where we have the basic formula for slope. So I'm going to zoom in just a little bit here. Okay, so mathematically, what we do is we get a difference in a couple of y values, and we get a difference in a couple of x values, and we divide those y value, the difference in the y values, by the difference in the x values. Okay, and you got a couple of points here. You'll see this one is a point called x1, y1, and this one's an x2, y2. It's completely arbitrary which one got numbered which. We just do this to be able to tell them apart. So this is some actual point. This is some actual point. And this is a general formula for finding the slope for any 2 points. All right, so let's go into Desmos and let's work out some slopes. So, and there's different ways to think about this, of course. We'll start off with just the basic approach that will always work mathematically. So I'm going to pick 2 points. I'm going to call one of them, we'll say 317, and the other one is going to be, we'll say 1422. Those are my 2 points. You can't see them on the graph right now because I got to zoom a little bit. Okay, so look at that. I've got these 2 points. And we could draw a vertical component of this, figure out the vertical change, and then a horizontal component of this. We call this vertical part oftentimes the rise, and it's called the rise because it's how much vertical change there is. This is the vertical change between this point and this point. And this basically going from a y value of 17 up to a y value of 22. This here is the run. Okay, and when we find slope, we divide the rise by the run. So slope is going to end up being the rise divided by, and I'm going to use a fraction bar to indicate divided by, rise over run. Okay, so conceptually, you could think of this. This is a rise from here to here, from 17 to 22. That's a rise of 5. And then this is the horizontal component. This is a run from 3 to 14. So that's 11. Okay, so that's a plus 11. And the sign will matter here. And this is a plus 5 from 17 to 22. So plus 5. Now, these numbers are reasonably close to each other, so we can kind of eyeball it. We can say, okay, what do I do to get from 17 to 22? I add 5. What do I do to get from 3 to 14? I'd add 11. Okay. And so I would end up, of course, over here with simply a slope of 5 over 11. And you might be tempted to turn that into 0.45454545 repeating or something like that. But I would recommend just leaving it as a fraction because it is currently set up for you to easily be able to graph things. Okay. Now, that's just sort of drawing a little, we got a little right angle triangle here. We can, if we want to, we can connect the dots, and now you've got a right triangle here. Okay, so the vertical and the horizontal make a right triangle. That'll be important later in geometry and algebra 2, by the way. But for right now, let's just work out the slope. So if I am calculating the slope, I'm not able to just eyeball it. What I'm going to do is I'm going to set up a little equation here. So this rise over run is going to be, so rise over run is going to be, I'll put it here so it's clear. So the y values, maybe we'll call it the first y value, maybe we'll call it the second y value. It doesn't matter what number you put here, as long as down here you put the same numbers in the same order. So we're going to call that x1 and x2. And the nice thing about subtraction is it tells you how far apart things are. That's actually kind of the point of subtraction, is to figure out how far apart things are. It's not just how much you take away, but how far apart are two things. That's why it's called a difference between y1 and y2. And so I'm going to actually go ahead and label this point 1, and this is going to be point 2. Actually, I'm going to change that up. Okay, I'm going to change that up. I'm going to call that point 1 and that point 2. And there's a reason I did that, but it's really because I'm being a little bit lazy. Avoiding dealing with subtraction that leads to negative answers. So if this is point 1 and this is point 2, I'm going to do y1 minus y2, and down here I'll be doing x1 minus x2. And that's going to get me the differences that are my rise and run. I'm going to ignore all this stuff here because I'm going to actually replace y1 with the y value from the point I've called point 1. There is no magical reason that is point 1. I just called it that. And now I'm going to take the y value from point 2, which is 17. Then I go down here and I replace x1 with the x value from point 1. And then I replace x2 with the x value from point 2. And I end up, well, you see this 0.4545, and you might be tempted to do some sort of decimal end. Don't do it. Don't do it. So 22 minus 17 is 5, and 14 minus 3 is 11. And that's what I said it was over here. Okay. Well, what if I actually reversed it? So that's really all there is to calculating the slope. Decide which point is point 1 and which one is point 2. Subtract the y's, subtract the x's, keeping it in the same direction that you did with the y's, and that'll give you the slope. Okay, what about if this was 0.1 and that's 0.2? That's no big deal. Let's recall this one. Now we'll call this will be 0.1 and this will be 0.2, and be like, but wait, Mr. Ward, I'm going to get some negatives. Well, that's okay. The negatives will take care of each other because they're both going to be negative, and then that's a positive. So now I'm going to go I'm going to say y1 minus y2. I'll say x1 minus x2, and I just got to replace y1 with the first y value. That'll be 17, and x, and then y2 with the y value for the second point. And then I'll go down here, and I'm going to subtract, replacing x1 with a 3, and I'm replacing x2 with the x value from the second point. And now I'm going to end up with -5. So that numerator is -5. And the denominator will be -11, because 17 minus 22 is -5. And 3 minus 14 is -11. Desmos puts that first negative out there, but it's associated with this 5. So this is -5 over -11. I can actually make that a little clearer by doing this. Parentheses around that 5, and then I can trap that negative in there. So -5 over -11, but wait, that's the exact same thing I had up here. What's going on here? Well, what's going on here is the negatives cancel out. Just like a negative times a negative is a positive, a negative divided by a negative is also a positive. Because frankly, division is a version of multiplication. It follows the same rules. Addition, subtraction, they follow other rules. They do not follow the same rules. So here you go. That's the slope. Oh, and by the way, I could have taken this and gone the other way. So instead of going a rise and a run, I could have done a fall. Fall is just the opposite of rise. So of -5, and a backtrack of -11. And I still end up with the same thing I had over here. Okay, so that's -5 over -11, which is 5 over 11. Okay, I'm going to pause the video in a second. Well, actually, before I pause the video, I'm going to give you some points to try really quickly, and then I want you to see how you do on them. So I'm going to give you pause here. So you should, see the screen suddenly changed a whole bunch. I cleaned up all the other stuff, and now I've given you 3 sets of points. I'm going to give you one more. I'm going to make a table here, and I want you to pause the video and see if you can come up with the slopes for these situations. All right, so I've given you some situations. You see, I may actually change the color for this. Make this one black. Okay, so I've given you 3 sets of points here, and also a table, which, if you look at those black dots, produces a linear situation. The linear situations will always have the same slope. So your challenge is to pause the video and work out what the slopes are for each one of these. So take a couple minutes to work out what the slope is for each of those. And now I give you some nice, relaxing music that you can use to calculate the slopes for these. You don't even have to pause. See what you can come up with. Okay, if you have the first one, if you have all of these, now you don't need to pause at this point, but if you haven't worked them all out yet, you may as well go ahead and pause the video. I will turn the music off for now. And here comes the answers. So for the first pair, 9, 18, 22, 30, you would have Done 30 minus 18 over 22 minus 9. So 30 minus 18 over 22 minus 9. Or these could both be in the opposite direction, and you'd still get the same answer. 30 minus 18 becomes 12, and 22 minus 9 becomes 13. So the slope is a rise of 12 and a run of 13 for these 2 points. And then for the next pair, negative 4, 5, and 4, negative 3, you could have do 5 minus negative 3 for the rise, which becomes 8, and negative 4 minus 4, which becomes the change in x, and that becomes negative 8. So 8 over negative 8 is negative 1. So the slope for that one is negative 1. The next batch here, I've got negative 3 minus negative 16, which gives me a 13 for the change in y, and negative 2 minus negative 5, which gives me a positive 3 for the change in x. So I get 13 over 3 for the slope there, a rise of 13 and a run of 3. Then here, I could have picked any pair of points, 4, 11, 6, 14, 8, 17. I went in and chose 4, 11, and 6, 14. And so I do change in y, 14 minus 11 over here, and change of x, 6 minus 4. 14 minus 11 gives us a 3, and 6 minus 4 gives us a 2 for a slope of 3 over 2. Okay, I hope that has been helpful.